I am going to start with your deep foundation. I have finished this earth pressure theories. Now it is deep foundation. Where is your deep foundations are required? Particularly soil at near ground surface is not capable of supporting a structure. That means a soil near ground surface not capable of supporting structure particularly if I am not getting a bearing capacity at the shallow foundations, the capacity I am not getting enough. At that point, what we are supposed to do, modify these foundations like isolated to strip or strap, combined, raft or mat foundations. If it is not possible, then we will go for deep foundations. There are two types. One is pile foundation, other is your well or caisson foundation. So, if I put it simple one pile, what is pile and what is well? Very simple one. Pile foundation is a long slender member, it is a very long slender member, either driven or cast in situ. Simple way, long slender member either it is driven or cast in situ. Means it is a long slender member. How it has to be installed? Either it has to be driven by means of hammer or cast in situ. Take a borehole, cast in the ground and put it. In details we will go. Well or caisson foundations to carry heavy load. To carry heavy loads. So, caissons diameter, particularly railway bridge, rails, these are called caissons or piers. Now, come to next step, that is your pile foundation. So, pile foundation may be used as a single pile, it can be used as a single pile or group of piles. This is a pile cap, there is a pile cap, this is my pile, either it is provided single or group of pile or it may provided as a battered pile to resist more lateral load. One is vertical, middle is vertical and one side you can put battered or you can put also both the sides also battered piles. This is called battered piles. In broadly, pile has been classified into two. In broadly, there are many classifications are there. One is called short pile another is called long pile. Short pile is called a rigid pile. Long pile also called as flexible pile. So, particularly what happened, very simple definition of short pile. If I put a ground surface here, simple definition, short pile is a rigid, soil fails earlier than the pile, very simple way as per the Poulos and Davis, you can take that book. Soil fails earlier than pile, that means pile is so rigid, soil fails earlier than the pile. If I take it a long pile, if I take it as a long pile, what will happen? Pile fails earlier than the soil, and pile fails by means of bending. Somewhere else hinge will be formed and it will fail by means of bending. So, this is a long pile or flexible pile, very simple. Details I will go one by one. Also another one Poulos has given, piles has been generally provided in a dimensionless form, L by B. L is your embedded length, L is embedded length, L by D, not B, sorry, L by D, D is your diameter. L by D is less than equal to 10, sometimes it is called short or rigid. Between L by D 10 to 20 or 30, it is called medium pile. It is a short pile. Then L by D greater than equal to 20 to 20 or more than 30, it is called long pile. Let us go to the other part of the pile classifications in detail, so that you have an idea how the classification has been made. So, types of pile, basically classification of the piles, or I can say types of pile, or I can say classification. So, this is based on, there are three parts. First one is your according to composition, second one is your according to method of installation, then third one is your according to your mode of transfer of load or by means of load transfer. Classifications or types of pile has been divided into three categories. First one is your based on your compositions, second one is your based on your method of installation, third one is your based on your load transfer. Let us start with first one. First one is your composition. According to compositions, it may be timber, it may be concrete, or it may be steel. First one is your timber. Timber pile is made of wood. So, length maximum you can take 15 meter, there are certain specifications. length maximum for timber pile, you can take it 15 meter, and dia generally 30 to 40 centimeter, and at butt, and it is equal to less than 15 centimeter at tip. In this case, maximum design load per pile should not greater than 250 kilonewton, should not greater than 250 kilonewton, because this is made up of wooden. Second one is your concrete. Second one is your concrete. In concrete again two types. One is your precast, other is your cast in situ. Maximum load on a precast pre-stressed concrete pile is 2000 kilonewton, and precast it is 1000 kilonewton. Optimum load range, optimum load range is 400 to 600 kilonewton. Then third one is your steel piles. Steel piles generally used to remove these corrosions. If there is a corrosion effect, generally in European and US, they prefer for a steel pile, depending upon your availability of the material. Sometimes to save your cost, the composition sometimes we consider. If plenty of wood or timbers are available, then you can go for timber pile. The limitation of this, it cannot take maximum load of 250 kilonewton, more than 250 kilonewton. Length you cannot go more than 15 meter. Then there is a concrete piles, either it is a precast or cast in situ. Pre-stressed concrete pile is your 2000 kilonewton, precast is your 1000 kilonewton, load range is your 400 to 600 kilonewton. Then there are steel piles, more discussion, I will giving more discussion later. Then second part is your method of installation. Method of installations again three types. First one is your driven pile, second one is your cast in situ piles, third one is your driven and cast in situ piles. Now come to your driven piles. First one is your driven pile. If you look at the driven piles, it generally what happens from the top by means of hammer, this pile has to be driven inside. Once it has been driven, so nearby the soil get disturbed. Primary aim of this driven pile, sometimes it is used to compact your soil. That is why it is called compaction piles. Then second one is your cast in situ. Second one is your cast in situ. Second one is your cast in situ. In cast in situ, what does it mean by cast in situ? You take the material. So, first what we are supposed to do? Make a larger borehole, then prepare the caging, steel caging in the field, and this caging will be inserted in the borehole. Then after that do the concreting. Cast in situ, that means everything has been done in the field step by step. So, cast in situ, it may be a straight shafted, it may be a straight shafted, or it may be under rimmed. Ball shape under rimmed, at the bottom it has been provided. So, to protect your particularly expansive soils where there is a expansion during the rainy season and during the hot season there is a contractions. So, there is kind of ball shape. Once soil expand, it will not exert uplift pressure on your foundations. So, this you can do it by means of cast in situ. Next is your driven and cast in situ. Driven and cast in situ, if I put it, in this case what will happen? This pile has been casted completely in the ground, in situ, in the field, completely casted. Taking caging and making the false ceiling, the pile has been casted. Then it has been driven. So, that is why it is called driven and cast in situ. So, it has been used over the water, particularly it has been used where there is a water, over water. There is a water is there, it is very difficult to go for borehole and place the caging. So, what will happen? You do the piling and bring it to the field, do the piling in the field, bring it in the field and simply drive it. That is why it is called driven and cast in situ. So, classification based on your mode of transfer, based on your transfer of load, so there are three types. First one is your end bearing, second one is your friction piles, third one is your combined end bearing and friction piles. So, what does it mean by end bearing? Suppose there is a rock bed at a shallow depth or maybe considerably reasonable depth below the ground surface. Generally pile at the end, pile has been inserted so that it rests on the rock bed. So, entire capacity, whatever the load coming onto the pile will be taken by your end point or end bearing. So, what does it mean? Transmits loads through their bottom tips so reasonable at a reasonable depth there is a hard strata or rock, then what will happen? Pile has been extended or driven or hammered up to your or pushed inside the ground surface up to your rock bed. So, that load transfer mechanism will be whatever the load is coming, it will be taken by your bottom or tip resistance. Then there is a friction pile. Friction pile means the load taken by the pile by means of your side frictions. What does it mean? In this case, do not reach your hard stratum. Do not reach your hard stratum. No need to push it very long to your hard stratum. Pile transfer the load through your screen friction. Load transfer through your skin friction. This is what I have shown, and it is called also floating pile. So, if this is my load, P is coming, here I can say it is QP, here it is your QS, Q frictional because of your side resistance. Now, combined end bearing and friction piles. Combined end bearing and friction piles, if you look at here, what does it mean? Combined end bearing friction pile means, if I draw it, load transfer from pile to ground or from superstructure to foundation, it will be by means of end bearing as well as frictional resistance. That means by means of QP as well as QS. That means it is combination of end bearing and friction piles. That means total load QU is equal to QP plus QS or QF. Let me put it frictional resistance QF. Here QU is equal to only by taken by frictional resistance. Here QU is equal to only QP. So, if I summarize, what are the different classifications? Types of piles as per the classifications. One is your compositions, by means of based of materials. Second is your method of installation. Third is your load transfer. Compositions is your timber, concrete and steel piles generally used. So, each having limitations as well as advantage. So, you will decide or take a call depending upon your availability of the materials. So, timber piles limitation, greatest limitation is maximum load it can take up to 250 kilonewton, beyond it is not advisable. Maximum length you can go up to 15 meter. Concrete it is precast as well as cast in situ. Then pre-stressed concrete pile load will be taken as 2000 kilonewton, precast 1000. So, steel piles particularly for corrosion, to prevent your corrosion effect, this steel pile has been used. Method of installations: driven, cast in situ, driven and cast in situ piles. Driven means the pile will be taken, then you drive it from the ground surface. So, once you drive it, nearby soil also get compacted. So, that is why it is called compaction piles. Cast in situ means you have to do everything in the ground. Take a borehole, prepare your caging in the ground, insert the caging, do the also concreting. It may be a straight shaft pile or it may be under rimmed ball shape piles. Driven and cast in situ, particularly which water table is there, in water is there, which is borehole cannot be done. In that case, pile cast it in the field, then same in situ you do this by means of driven. Then load transfer, three types: end bearing, friction piles, combined end bearing and friction piles. End bearing means if there is a pile, the load, entire load to the pile will be taken by your end or tip of the pile. Friction pile means if there is a load coming to the pile, so it will be transferred by means of side friction or skin frictions. Combined end bearing and friction piles means, so load will be transferred from superstructure to foundations by means of friction, side friction as well as tip resistance. So, Qu is equal to, in this case, end bearing Qp, here Qu is equal to frictional resistance Qf, here Qu is equal to Qp plus Qf. I will stop it here. So, next class we will go in details about the pile foundations. Thank you.